I still got one more minute.
You called? You called?
Hold on.
I got a meeting starting it, so I gotta talk quick.
Tom.
Okay, yeah, I'm at the primary place. Okay.
There's no guy to take a bottle out for this. You ready? Okay.
Oh, there he is. The first guy we need to talk to is just walking in here. Stan, take your seat. We need to talk to you. You're number one on the runway tonight. Stan just came back from Timbuktu, X-Bar Ranch. Thank you. Okay, so it's 7:30 and we are going to get started. So welcome to the August meeting of the Johnson Space Center Astronomical Society. And for our opening slide, we have a really beautiful picture from Stan. And Stan, would you like to tell us anything about your picture?
Okay, this was taken at a remote site, West Kerr Ranch, 402, June 11th, his birthday. It was very windy and very cloudy most of the nights, and only got about an hour's worth of, I don't remember exactly, only about an hour's worth of images. 33 each, 33, I guess it's an hour and a half. Yeah, 1.65 hours. But anyway, it's Ophiuchi, at least my rendition. Plus I have some of the dark nebulas going back over to the Milky Way with that bright yellow orangish star there is Antares. And M4, the globular cluster, is right below it to the right. And if you're familiar with Scorpio, you've got Antares, you've got a couple of stars either side of it. One of them is the very bottom center, and one is on the right, kind of in an arc there. But they're totally different colored stars, and actually Ophiuchi is up there, the bluish area. It's real strange. Ophiuchi comes right down in there, and one of those stars is right next to Scorpio. But anyway, there's a couple of other globular clusters in there, one close to Antares, a little upper right. I've forgotten the number. Let's see.
Is that M80?
I think M80 is off, right, it might be right above your head.
Oh, I thought it was that one.
Could be. I forgot to put that in there, but there's a third globular that may not be in that image, probably up there where JSC is, but there's a third one.
That's not a cluster over there by image by Stan? That's not a cluster?
I think that is a cluster.
Looks like one to me.
Well, I know there's 3 globular clusters in that general region, and I was able to capture this week. I went to El Dorado X-Bar for a week, and I got a lot more data, a lot better data. That was from my home.
Okay, thank you very much. Alrighty. This is our agenda for this evening. And before we get started, we'd like to welcome anyone who this is your first time here. First time here, raise your name, tell us your name, how you found out about us, and what your interest is in astronomy. Okay, I know it's your first time here, right?
No, I've been here several times before.
Oh, sorry.
I've been here for a few, probably about a year or two.
Okay, year or two, forget it. But your name's Rainier? Reiner. There he
That's
is.
not my count's first time, but it's the first time I've been in this building.
Okay,
I was a member for 20 years or something.
yeah, what's your name?
John Moffett.
John Moffett. And how and you know about us from forever, and what's your interest in astronomy?
I'm a theoretical astrophysicist, geologist, paleontologist. And I actually had an offer from Mission Control once to work in Mission Control, turned it down, went a different direction. So I actually never worked at NASA.
A wise choice. Okay, very good. Thank you. Anyone else first time here? No. All righty. Okay, so if you'd like to get on our email distribution list, you can send a note to David at starhopper457@gmail.com. And if you can't get that email address written down up there, Brandon's holding up our clipboard. You can take off one of the tear off tabs and that has David's email address on it. You can shoot him an email and say, hey, I want to get on your email distribution. All right, reminder to presenters. Leonard, please use this mouse pointer that's built into the computer, please, with the mouse pad. Then the people online can see what you're pointing at. And then the stream mic is built into this laptop, and the auditorium mic is this guy here. So you pretty much got to stay in this general area for everyone to be able to hear you. So don't go wandering off, because if you do, then people online can't hear what you're saying. All righty. Reminder, please no conversations in the auditorium during presentations. We want to be polite to our presenters. Okay, so our main speaker this evening is Leonard Ferguson. And if you've ever been here for one of Leonard's presentations, you know they are just excellent. They are top notch, one of our best speakers we ever had, and we're really lucky to have him tonight. He's going to be talking to us about expanding our view, the Nancy Grace Roman Space Telescope. And I'm going to tell you a little bit about Leonard before he comes down here. I know he's ready. Leonard Ferguson is an active amateur astronomer with a particular interest in our sun and variable stars. He is a longtime volunteer at the Houston Museum of Natural Sciences George Observatory, conducting classroom presentations during public star parties and assisting with the operation of the dome telescopes. He's an active Fort Bend Astronomy Club. He's active in the Fort Bend Astronomy Club, assisting with educational programs and helping to support and organize club meetings and activities, and write stargazing articles for several publications. So join me in welcoming Leonard Ferguson.
Good evening, everybody. We're going to have trouble with this wandering off thing because that's my number one tendency. So, okay, so everybody familiar with this mission? Okay, that's why we're okay. All right, so yeah, this is going to be our next flagship mission, our next space-based telescope, and they're actually originally scheduled to launch May of next year, and so they moved up the launch 9 months to the end of this month. So we're going to be launching early morning, August 30th. I've got a slide on that at the end. And so with that, all right, we'll skip this because that should have been on that slide. Okay, so launching August 30th. I've got some more specifics on the launch later. Will be a 5-year mission, and it is going to operate out that 930,000 miles from Earth. That's going to operate at the L2 Lagrange point. So I'm sure most of y'all are familiar. I do have a little bit on the Lagrange points for people that are not familiar. So we'll cover that. And then primary mirror there is 7.9 feet in diameter. It's exactly the same size as Hubble's. The difference is this will be a near infrared telescope. So first we'll talk about how the telescope got its name, Nancy Grace Roman. She was NASA's first chief of astronomy. And like many of us in here, she got interested in astronomy at a very young age. She formed her own astronomy club at the age of 11. And so that group met weekly learning about the constellations. She eventually went on to college, study astronomy, and entered graduate school at the University of Chicago. And she took on a research assistant position there. And then in 1954, she was recommended by Gerard Kuiper to a position at the National Research Laboratory, and where they had a brand new field called radio astronomy. So she took that position and was there for 4 or 5 years. And then late 1958, she was contacted by somebody from a brand new organization you may have heard of, called the National Aeronautics and Space Administration, that they were looking to start a space-based astronomy program. So she made application, was offered the position, and accepted it, and started at NASA early 1959, about 6 months after the organization was formed. And then she took on the position of chief of astronomy just about a year later, 1960. So then she had this group. They built several orbiting telescopes, some solar orbiting observatories, and then, of course, Hubble came about in 1971. So her main, one of her main accomplishments that we hear about is that she was instrumental in shepherding Hubble through the entire process of getting it approved, getting it through Congress, and seeing that mission accomplished. So today she is recognized as the mother of the Hubble Space Telescope. So the mission we're talking about tonight was starting to be implemented in 2016, and it was actually approved for implementation in March of 2020. And then in May of that same year, NASA made an announcement that the mission that was originally called the Wide Field Infrared Survey Telescope would now be named Nancy Grace Roman Telescope. So a little bit of background there. And here it is. So this is at Goddard. This is a couple of months old, going through some of the final checkout procedures here. But, just put this in here to give you an idea how large it is. Got some humans in here for scale, so y'all can get an idea. Roughly, with that mirror, it's roughly the same size as Hubble. And I just put this in because I thought it was a cool shot. So, gorgeous mirror.
That's a 410-pound mirror?
410, yes, sir.
Yeah, so the spacecraft is considerably heavier.
Right, correct. Okay, so if we're familiar with Webb, that operates out at the L2 Lagrange point, which I'll cover on the next slide. Euclid, that's a European Space Agency mission that launched in June of 2023. Euclid and Roman are going to be kind of complementary. They're both doing the same thing. Euclid is doing wide field surveys in visible light, where Roman will be doing wide field surveys in infrared light. So there's going to be a lot of collaboration with ESA between these two missions. And of course, history from Hubble and Fermi. We've got Fermi in orbit. Fermi's in about a little bit higher orbit than Hubble, about 375 miles. And Chandra, Fermi's gamma ray, Chandra is X-ray. So all of these missions are complementary. Everything we learn from these are going into, our knowledge base. All right, so Lagrange points. Roman is going to operate there at L2. But I'm going to skip ahead a little bit and go to L4 and 5. So these were identified by Joseph Louis Lagrange in the early 1770s, that these points exist in space in any two what we call large mass bodies. So the sun, Earth, Earth, Moon, Earth, Jupiter, these points exist. If the mass ratio is at a certain level, which they are with Earth and the sun, Earth and Jupiter, L4 and L5 are stable points. And Lagrange speculated that asteroids would probably get caught up in these, and basically they're there forever. They kind of work like the way they explain it, like a low spot in a bowl. So these asteroids will drift in there and they just drift around in there forever. So he predicted that in early 1772. It wasn't until 1906 that we actually confirmed the first asteroid was out there. So you've probably seen this image or one similar to it. And we see those asteroids out at, what are the asteroids out at Jupiter called? Trojan asteroids. So in there, if you can see, and I'm going to turn the image here to align this the same way, and you can see all those asteroids captured at the L4 and L5 points. And so right now, I think they know of about 15,000, but they speculate there may be as much as 1 million asteroids captured there between the 2 points. All of those be larger than a kilometer in diameter.
So why aren't there any asteroids at the L2 point?
I'll cover that.
Okay.
Let me come back. All right, so it's L3 and L4. L3 and L4 are stable. L1, 2, and 3 are unstable. They're at the top of the hill, exactly. That's a good analogy there. So if you're at the top of the hill, you can stay there pretty easily, right? But a little bit, get to the edge, get a little nudge, and just try to fall off. So that's kind of the good way to think about these. L2, now you can see how L2 and L1 works between Earth and the sun, right? So that's gravitational points are balanced. L2 is a combination of the sun and Earth, balanced against the centrifugal forces, the orbital forces going around there. L3 is on the far side, and that's a combination of the forces in Sun and Earth. So all of these are balance points, or points of equilibrium out in space. And so because they're easy spots to maintain that, they're a really good spot to park a spacecraft. So L1, if you remember SOHO, Solar and Heliophysics Observatory, it's parked at L1. Been there. It had a 3-year mission, was put up 1995, and it's been there over 30 years, still operating. So SOHO's parked there. L2, we've got several spacecraft. Euclid is there. Webb is there. Gaia, European Space Agency, Gaia that was launched a while back, it's at L2. So you can stay at these points, but it's not just a fixed point in space. You don't just sit there forever. So these objects tend to drift around in a halo orbit around here. Webb's orbit is about the size of Earth's moon around the Earth. So it's not a tight orbit. It's a pretty sizable orbit. I believe Roman's is going to be about the same. So, but natural objects they will get captured, they'll stay for a while, and then they tend to drift out. So it is a point of capture. There is extra stuff there, but they don't stay forever like they do at L4 and L5.
Are these points orbiting with the Earth?
Yes, they follow us around in the Earth. So, and see L4 and L5, those always make, that's a 60-degree angle. So those always make an equilateral triangle going around. Those vectors are always balanced.
And are there like ranging points associated with other planets?
Yes. Yeah. The Earth and Moon, Sun and Jupiter, and the other large planets. Anywhere there's two large bodies, I think technically or theoretically, any size body, as long as they have a gravitational interaction, they're going to be there's going to have to be some sort of Lagrange point there. Right? Okay, so back to this slide. So we will have Roman out there, and all of these, again, this is all information that we're gathering, and these are going into our big database, and we're going to have another mission that I'm going to talk about in a little bit, that all of these will become important. So you see there, planets by the thousands, stars by the billions, galaxies by the millions. Roman is going to have one survey instrument called the Wide Field Instrument, and is going to be able to do all of these. And there's really only 2 instruments on board, but the Wide Field Instrument, here you can see Webb and Hubble's field of view, and then Roman there. Roman is going to have that field of view. It's about probably close to 100 times Webb or Hubble. It's going to image in the same detail as Hubble, down to the milliarc second resolution, and about 1,000 times faster than Hubble. So, and you can see down at the bottom there, we have, the Roman, it's kind of overlaps, kind of complementary to Hubble's near infrared abilities. We're going to be able to use all the Hubble data we've gathered over the years and compare it, and using Roman to do that. So, okay. All right, we'll cover the Wide Field Instrument first, which looks like this. It's 18 detectors. They are infrared detectors. They're also able to, the camera also has spectrographic capabilities to process that light. So those are going to be the 2 main science abilities of Roman, but you can see that makes up a 300 megapixel camera. So that's going to be a lot of data coming down. So to give you an example here, if you see the blue area here, that's Hubble, what they called so that was the Panchromatic Hubble Andromeda Treasury Survey. This was done back in 2012. So that blue area took Hubble over 400 individual pointings to image that, about a third of the Andromeda galaxy. So over 400 images, 650 hours of imaging time to do this survey with Hubble. And then overlap, you can see Roman's field of view can do that same thing, 2 pointings, 30 minutes of imaging time to do the same thing. So far more powerful. All right, so the objectives of this mission, I'm going to start there in the middle. Dark energy and dark matter. Those are two of the main objectives. Of course, all of these you see, these are the big questions in front of us now. We see these on a lot of missions, right? How did the universe get here? What are other planets like? And are we alone? So all of these are going to help us answer these. Are we alone? I don't know if we can we ever answer that? Yes. I don't think we can, because as humans, we're going to keep exploring, right? As long as we don't have an answer, we're going to keep looking. So,
If they land on the White House lawn.
yeah. But even so, if you think, I think we would still keep looking,
Oh, yeah.
maybe more intensely. So, as humans, we're explorers. So that's in our nature. So that's where these big questions come from. But newer questions there. Are we alone? That's probably going back to the very earliest humans, since we started looking up at the sky, right? But how did the universe form, and what are other planets? Those are maybe newer questions. We're going to try to answer some of those and get some info. So we're going to start out with several surveys. One is called the High Latitude Wide Area Survey. We're going to start with these blue areas. That image to the middle, of course, that's the plane of the Milky Way. So high latitude, we're going to be looking above and below the plane of our galaxy, looking out into deep space and imaging those areas. This is where we're going to start trying to get some ideas of dark matter. So dark matter and dark energy combined make up 95% of our universe, as far as we can tell. What we call ordinary matter only makes up about 5%. So dark energy alone, I think, is 27%. So we don't know what it is. We can't see it with our telescopes, and we don't know much about it. What Roman is going to do is take a look at all these galaxies, hundreds of millions of galaxies over its 5-year mission. And it's going to take high-resolution images and look at how gravity is distorting the images of these galaxies over long distances in space, and try to get an idea of how dark matter appears to be some force that's holding everything together, kind of like the glue that's holding everything together. So it's going to try to get an idea and see what the distortions of these galaxies in the imagery, and process that. And so, kind of conversely, with dark energy, we're going to do the same images, but look at how these galaxies are moving over time by using the spectrographic capabilities of the Wide Field Instrument, and look at how these galaxies are moving. Combining those two, they expect to be able to make up a 3D map of the entire universe out to 11.5 billion years over the 5 years of this primary mission. And then we have the high latitude, what they call the time domain survey. So what's going to happen here is they're going to identify spots like we have here, and they're going to return to these. They're going to image them, go off and do another campaign, and then come back and repeatedly image the same areas over and over. They're going to be looking for type 1A supernova. So those are, we consider those standard candles, because those events happen at a specific mass. And when a star explodes in that particular supernova, the light curve is very specific. So we can use those to accurately measure distances across space. So by doing this, they hope to measure all these supernova, get very accurate light curves, and be able to refine the distances out there. They say they expect to find 20,000 type 1A supernovas over the course of the mission. And those are very rare events. So, all right, any questions so far?
There's a red dot. Oh.
Yeah, that's the mouse.
Oh. That's
Sorry, I should be using that. Are we good with that?
That's a type 2 supernova.
That's a type 2. Oh, here's a supernova. So, okay. All right. Now this is, I said there's only one survey, and it does have a second instrument, but this is considered a technology demonstration. It's called the coronagraph. So any of y'all that are familiar with coronagraphs these days, there's usually some sort of a disc or a bar an occultation bar they put in front of a star to try to cancel out the glare from a star if we're going to try to image an exoplanet around another star. This new one that they've developed it's got a whole system of lenses and filters, and it's got some special flexible mirrors that they developed. And what they can do with this is cancel out. They can look straight at a star, and they cancel the star out. It's called destructive interference. And so they cancel the starlight out by moving this thing around and canceling at different frequencies. And it brings theoretically will bring out an exoplanet next to its star. The coronagraph, if it operates like they say, will be able to image a planet that is 1/1000th of the light of its star. So here's a big number. They think they can discover in the core of our galaxy up to 100,000 more exoplanets. We only know of 6,000 plus right now. They're expecting to find 100,000 more. So when they prove this technology, so again, technology demonstration, this is going to be incorporated. We have another observatory coming up. It's probably about 15 years out. It's called the Habitable Worlds Observatory. Probably going to launch in the 2040s. It's going to combine all these capabilities, infrared from Webb and Roman, visual from Hubble, and all of these, roll this all up into one observatory that is designed to go out and look specifically at planets around other stars. And they think that this observatory will be able to directly image planets around other stars at that point using this type of technology.
How much longer are they currently planning to use Hubble? 'Cause it was supposed to be no extension.
So when they did the last servicing mission, which was 2011, they expected to get 5 years. That was the goal, 5 more years of Hubble.
You're talking 2040 and
So,
joining Hubble, I just wondered if it's still going to be.
well, say joining, using the information we've learned from Hubble, all of this is going to be maybe heritage information at that point. But and some of these,
I guess we could service it again.
so I don't know the answer to that. Okay, so here's our exoplanet. So again, we know of 6,000, a little over 6,000 right now, and we hope to add 100,000 exoplanets to that count.
Are there any plans to go back and confirm using this new method, the 6,000 that they discovered?
That's a good question. I don't know the answer to that. I will look that up. That is a good question. So, all right, so data, another big number. Hubble has produced 172 terabytes over its first 30 years, and they expect Roman to produce 20,000. So I've got a little video. My last slide is a little video of the assembly of the telescope, and you'll see a shot of the communication disk, which is a little over 5 feet in diameter, but that's a specially designed communication disk designed for this high data output. Because if you count this, Roman's going to be producing the amount of data in a couple of days that Hubble produced over its entire 30 years, or the beginning of its lifetime. So I think the downlink speed for Roman is about 500 megabits per second. Who has that? I don't know about the network now. They're not going to use the deep space network. It's there. They'll have that for backup, but they're using, I think it's called the Near Space Network. There's a antenna out at White Sands, and they're going to be collaborating with one with JAXA over in Japan, and then a European Space Agency antenna down in Australia. So that's the primary network that the Roman will use. Yeah, that's a lot of data, and over that distance, you lose something over 1 million miles of space. It's not like we're in low orbit either. So lots and lots of data. Okay, launch day coming up. What, 16 days? Sunday morning, August 30th, 7:26 Eastern. That's of course 6:26 our time. launch on a Falcon Heavy off Launch Complex 39A. So this was originally was going to be a Falcon Heavy fully expendable, where they would not attempt to recover any of the boosters. But I actually just heard earlier this week that they have made some changes to the ascent profile, and they're going to actually try to recover the boosters on this one. So we'll see how that goes. And that, as far as I can tell, those are not on a barge. They're going to land back at Cape Canaveral. So we'll have to see how that one goes. So, okay, looking ahead, we've got launch. Commissioning will be about 3 months. So launch, I think the spacecraft will separate from the upper stage about 30 minutes after launch. And then shortly they're going to do, it's only like 110-second burn to put it on the course for L2. But they're going to spend about 3 months getting out there, checking the telescope out as we go. And then first look, or so they like to release first look. We should expect that probably beginning of December or so. And hopefully we'll see some first images. And then after that, we'll move into science orbit and continue with 5-year mission. All right. That's all I got. I got one more slide. Any questions? Yes, sir.
Yeah, what do they think the lifetime of the mission is going to be? How long do you think it's going to last?
So 5 years is a goal. I think there's an option for 5 more because they do have, with Webb is a 5-year mission, but they did such a good job getting it to L2. They actually have enough fuel on board to go. I think last I heard 20 years to keep it at L2 for 20 years. So same way with Roman, I think. They'll try to get it there with 10 years of fuel, but these launch teams do a good job and get them there and save fuel. They have more fuel to stay there.
So I got another question, but I don't know. So Leonard, do you have any idea the sensors on this thing, are they silicon sensors? Silicon does work in near infrared. Do you know, are they silicon or is it something else?
I do not know.
Okay. All right, that's fine.
Do not know.
I suppose they did a better job of testing the mirrors than they did
I'd have to start by actually testing.
We'll assume yes, I think.
All right. Well, I've got one more slide here, and it's a nice video. It's about 2 minutes video of the assembly, and I will leave y'all with that. Takes a few minutes for it to start. Maybe.
15 seconds, I think.
Don't crash the SpaceX rocket.
There we go.
That's the imaging assembly.
Okay, Leonard, thank you very much for that very fine presentation. Okay, Ron, or Rick, sorry. I saw Ron written here. Rick, tell us.
We've got some DVDs up there to give away. Just go ahead and grab one. And we've also got some sky and telescopes. And thank goodness we were running really low on the sky and telescope. Who is it?
Jerry,
Jerry.
our hero.
Jerry just gave us about another 8 to 10 months worth of sky and telescopes. So we will continue the giveaway. So my thanks.
And Brandon was just holding those up. They're up there at the table. Free to anyone who wants to take one. All right, and there's Chris Wells. Welcome, Chris. All righty. Okay, so the meeting after the meeting, when we get done here, we'll get together at Mod Pizza. It's the one in front of HEB at Clear Lake City Boulevard in El Dorado. Everyone's welcome to attend. I see some waving arms back there. You guys excited about Mod Pizza? All right. Get together and talk about the Nancy Grace Roman telescope and anything else we feel like talking about. Everyone's welcome to come. Okay, so we will take a 10-minute break and then we will get back with the second half of our meeting. See you in 10 minutes.
Good. We finally got my slide.
My luck, no. I never win anything. I give it
You by yourself there. Was it empty there? That's a lot of Yeah, it's kind of like and the ESP. I'm gonna go. I'll show up early to the X bar. That way I get the full 6 days. I'll show up early. I want to go because I don't get to do it that often. I want to have a business.
No, that's not really.
Oh, this year? Oh, that big party. That was live. That
Okay, 10 minutes is up and we're going to get started. Second half of our meeting, we're going to get started. I am using the microphone. You can't hear me? I am so sorry. Can you hear me now? Chris, you really can't hear me up there? Okay, anyway, I don't know what to do. The mic's here. That's how loud I talk. I think there's only one volume. Jerry, can you hear me? Okay, Chris, you get that earwax cleaned out of your ears, man. Okay, so we're going to get started here. Second half of our meeting. Okay, so I have a DIY astronomy, summertime astronomy, and M17. So last month, Reed over there had an image of M17 on our opening slide, and it made me start thinking, why, oh, why don't we do more summertime astronomy projects? Because if you look at the summertime sky, it's just filled with excellent celestial objects. Every one of these squares out here is a notable celestial object in the summertime sky. But it's hot and there's mosquitoes. So that's some of the reasons. But, for our personal comfort, one thing we can do, obviously, is we can remote control our telescopes, sit in our nice air-conditioned house and remote control them. But it still affects how noisy our pictures are. Right? The heat increases the amount of noise. Noise current in silicon is proportional to the square root of temperature. So here's a section of a dark frame that I took in July, 10-minute dark frame, but I could only get my sensor down to +4 degrees Celsius because of the heat outside, and wound up with pretty noisy images. And aside, not related, but this particular dark frame also had these cosmic ray hits in it. Not temperature related, but something else that we have to deal with when we're doing imaging. Another challenge, of course, is when we image from our house, we have light pollution. Our house is on the border of Bortle 8 and Bortle 9 areas. So in case you're not familiar with the Bortle scale, Bortle 1 is very dark, and Bortle 9 is very awful. So that's the way it is. And on top of that, there's a street light out in front of our house. Yippee. So it makes it even better. And it's one of those ugly, blue, LED blue ones. Oh, I have a question. What's the question?
What if we're mosquito in the fitness, we just all wear suits that have tiny doors inside that are very dark?
Okay, say that one more time.
What if for mosquitoes and heat, we just all wear bee suits that have little coolers inside that are super wet and care of?
That's a really good idea, but I'd rather sit inside my air-conditioned house and remote control my telescope. But that is a good idea. If you're outside, you can get a special suit like he's suggesting, and you can stay outside with the mosquitoes and fight them off. Great idea. Thank you for that suggestion. Okay, so one option, of course, is we can do narrowband imaging for our light pollution, where we pass just certain wavelengths of light that we're interested in and block all others, and that will help us with our light pollution. This works very well for emission nebula. Okay, so a good summertime project, M17, Swan Nebula. So for this project, we'll use an 8-inch Ritchie-Chrétien at f8, narrowband filters, a CCD camera, Los Mandy mount, and an off-axis guider. And here are the individual images from the different elements: hydrogen, oxygen, and sulfur. So this target is pretty strong in hydrogen and oxygen, as you can see, and it's less strong in sulfur, but still usable, right? And also on this particular setup, I only did for calibration, we used dark frames, no flats, no dark flats, and no biases. There's another thing nice about narrowband imaging. You can get away with less calibration frames. And here's the end result. Now, so the point of this is, even though it's hot outside and we have light pollution, there are ways to get reasonably okay results. You can do it. It can be done. And there's my webpage at the bottom. If you'd like to see this picture and my others, you can look there. And that, to me, just looks absolutely horrible on that projector. I'm sorry you have to see it in that condition, but if you look at it on my webpage, it looks a whole lot better than that. Let me tell you.
That's a Hubble palette, right?
That's Hubble palette.
Which one?
SHO. Yeah, so it's a thing called the Hubble palette, where sulfur S is mapped to red, and hydrogen is mapped to green, and oxygen is mapped to blue. So you can see this really hot oxygen area here, which is blue. And that's the one that's called traditionally the Hubble palette, because that's the one that they started. And then after that, the amateurs started getting narrowband filters, and they did the same ones that Hubble were doing, which is hydrogen, sulfur, and oxygen, the most common ones. There's other narrowband filters, but those are the common ones. Yes?
Sorry, could you repeat that for the three colors? For the three...
Yeah, SHO, which is S, which is sulfur, is mapped to red. H, which is hydrogen, which is mapped to green. And oxygen is blue, mapped to blue. And it's really, sulfur is actually S2, and the hydrogen is actually hydrogen alpha, and the oxygen is actually O3. So it's not just normal. For example, the O3 is a forbidden thing. We actually can't produce it on the Earth, but it happens in space. So O3 is something that we can image with our telescopes. We actually can't produce in a laboratory. Yeah, it's kind of cool. So, all right. Any other questions about this? Look on the webpage. It looks a whole lot better. Oh, one more thing. One more thing. Astronomy trivia. M17 has at least 4 names. What are they?
Swan, Omega,
Okay, wait a minute. One at a time. Swan. What was the second one?
Omega,
Omega.
M17.
Anybody know the other
I
two?
don't know the-
There's 2 more. Anybody know the other 2? Okay. They are the Lobster Nebula and also the Checkmark Nebula. So, whatever. I don't name these things. Okay. Thank you very much on that. Now, next thing up, club officer election. So I'm going to ask Rick and Brandon and B to join me up here at the front, please. All right, well, they're coming up here. Okay, so you guys know when a company becomes really, really successful, how they have to bring on like more than one vice president? You guys know about that, right? So the JSC Astronomical Society is kind of at that point now where we are just doing so good, we need an additional vice president. So the idea is, yes, we are going to have an election tonight to vote in Rick as our another vice president. If you don't know Rick, he's a former NASA guy. He's been active in the club for the last few years, and he actually was the vice president at a local amateur radio club. So he's got experience doing things like that. So the vote is to vote Rick in as the second vice president, yes or no. If you vote no, we'll just come up with another plan. And the idea is for Rick to be vice president for some period of time for the purpose of becoming president in the future. So any questions, Mark?
In the meantime, does the second vice president have any duties?
Of course. In fact, he's going to run the next meeting.
Yeah.
I'm out of here. No,
Congratulations.
No JT.
I shouldn't have told you that. No. Yeah, no, of course. Yes. Everybody in the club. Yeah, we have things we do. You think he's just going to slough off?
I just wondered what the organizational structure is.
Oh, that's the organizational structure right there. Okay. Any other questions about what we're doing here? I thought for sure someone would ask me how long I've been president. What?
The next formal election. When does he succeed and become the president?
Well, we'll see how it goes. Well, it's kind of up to Rick. We'll let him be vice president for a little while. And if he feels comfortable in the near future, maybe December-ish, maybe we'll have another election. But it's kind of up to him to see when he feels comfortable. Yes.
So just like your company, we have a senior vice president and a junior vice president?
No, we have a senior president. And there's many reasons for that. And then we have two vice presidents, which are get along just great. And they're going to just work together. And it's going to be one big happy family here. Okay. Any other questions? All right, good. So B is going to come up here and run our election. We're going to leave the
We
room.
have to, now
We're going to leave the room. And you guys vote.
We may be unemployed.
And if you're here tonight, you can vote.
So my responsibility just count the number. Okay, close the door. All right. If you agree, vote yes. Please raise your hand. I guess I don't need to count. Anybody? No? Nah, we're good. We can get them back. All right. Hey, guys.
They got them on pizza.
They left us here.
That's okay. I can get them back. Thank you for your.
Thank you.
Thank you, B.
You think I'm back?
Oh,
Oh, no. Oh, yes.
Okay, Rick.
Oh, we should mention, we voted the second vice president buys the pizza.
Oh, I think that's a really good idea. I like that idea. Okay, guys, thank you for cooperating with that. All right, members minute. We have Chris Wells tonight. There he is. Mr. Chris is going to come down and bring us Falcon Rocket Lunar Impact Imaging Attempt. What am I? Why am I the only one? Oh, Chris.
Well, first of all, donation from Angela, big donation of brand new books. Yes.
For the door prizes?
So for the door prizes later, so you get to see what those are, but all thanks go to Angela. So
They're
thank
not marriage books, are they?
you. How to survive marriage? You mean? No, they're not. That's pretty funny. Okay. Is there a pointer on here, Doug?
Yeah, you move the mouse pad around. Just see that red thing?
Oh yeah.
Yeah.
Yeah. And then how do we step forward here?
Just hit return.
Enter.
Enter. Sorry.
Okay. So first of all, the title of this is the Falcon Rocket Lunar Impact Imaging Attempt. Okay. And I think as far as I know, it was really the South Koreans who managed to image it, the Januri spacecraft. And my imaging attempt, no. Set some expectations here. It was an attempt, and I underline the word attempt there. But it was fun trying, and I want to show you what I was able to see. Okay, so for this members minute, I'm going to give you. It's going to be a theme about rockets. Okay, so it's more than just that Falcon rocket. It's also some other rocket imagery, and you're going to have to help me tell me what these items are. So, first things first is okay. Got a little video. Please run. Please run.
I think he just hit enter.
Oh, yeah. Here you go.
There it goes.
Can you see it?
Yeah.
Okay. And it's going to run. Oh, we got a pointer, didn't I? Okay.
Yeah,
So-
it'll repeat over.
So it keeps repeating over, but you see it coming down here. So this was on April the 21st, and this is taken from the what Angela and I are calling the lazy astronomer cabin, because we don't like to get all the equipment outside anymore. This is actually from an all-sky camera and a video of various composition frames that were just stacked together and made into a video. So each of the frames are about 30 seconds apiece, and we just happened to catch this. So first of all, credit to Hawkeye's here, Trevor, who actually found it first. He said, "What's this? What do I see in this video here?" Well, it looks like some kind of spent rocket. If you look at it carefully, it actually starts as one, then it goes into two, and then it starts to spiral. I don't know if you can see in the light here how it starts to spiral, but it's quite an interesting object, and not a deep sky object, but it's definitely something like a spent rocket. But interesting is I did do like a Google search on that date and time to try and find out what it is. And I don't know about you, the more you search on the internet now, the more you find misinformation. It's really hard to know the good, credible sources. So I'm not quite sure what it is still, or what item it was. But I can watch this a few hundred times. I enjoy watching this video here. Okay, next slide. So, what am I doing here? Okay, so there's a freeze capture of just one of those 30-second images. And you see I've sort of zoomed in a little bit on the top left there on what it looks like, where one object seems to have like almost two areas that come out from the center there. So that, what are those? Are those the rocket boosters coming away? What are those? Question at the back there. Well, I think it's a spent rocket. The camera picked up a spent rocket.
Can you put the mouse on it?
Yeah.
Oh,
Point at what
shoot.
you're looking at, Chris.
Yeah,
Have the mouse point.
I don't know.
It may not lie there, it's hard to see.
Okay, so
Right up there.
right up there. Yeah, and that's kind of zoomed in a little bit, so you can see a center section with like two bars right next to it. Then further down, you can see it almost looks like a spiral galaxy as it started to spiral down.
Oh, that's the same object?
That's the same object, about 30 seconds later.
Oh, I thought you caught a spiral galaxy.
No. No. Looks like a spiral galaxy, like the fireworks galaxy maybe. But no, that's the same object a little bit further down that's starting to spiral out. So I thought that was pretty cool looking, but I can't say exactly what it is. And so if anyone wants to, you think it's a
Flume?
a flume?
Flume.
The gas, the ejecta coming out of the rocket.
Oh, okay. Okay. Maybe.
I mean, I've seen one like that before right overhead.
Okay. So how do we find out though? How do we find out for sure what it is?
Well, I know the one we saw, you had to look up when the SpaceX launch happened, and then you count how many orbits later. It's usually an orbit or two later.
Okay.
Like they have some telemetry data. You can look that up.
Yeah. So this is about 4 o'clock in the morning, Central Daylight Time on April the 4th. So when I Googled that, I couldn't really correlate it with anything. So at least not with the resources I was finding, but there's so much misinformation out there. I couldn't.
Was there a launch that day, like a few hours before that?
There was, yeah. So it could have been earlier, is what you said. Yeah, maybe. So I thought that was pretty cool. That was pretty cool. So once again, that's another example of being indoors. The camera's doing this all for you, And
Doing it in North Carolina, we're just sitting here.
right. So we dial in remotely and we can see every night this camera is an all sky camera. It's mounted temporarily in the gutter of the property. And it so far has only fallen out of the gutter once, I think. So, well, I got a good picture of that. So one of the things the all sky camera does is also take star trails for the whole night. So we actually know where north is based on that position. So north is there, and it also caught the streak coming down here. So if that's north, that's south. So that's coming from the south. So I did exactly that. I went to Google and I said, well, here's the Lazy Astronomer cabin. It's in North Carolina. What is roughly due south? Florida, right? It's actually Florida. So it's obviously, it looks like it had been a launch somewhere there off of one of the launch sites there in Florida. Possibly. So. Yeah, the star trail was kind of cool because it gave you, because I was scratching my head too, thinking, well, what is the orientation of the cabin? And I didn't quite know. And then all of a sudden I was like, well, the star trail image tells me that exactly what's. Yeah.
So is that star trail, is that just like one big long exposure?
Yeah, so this is an entire night of exposures. Each exposure is 30 seconds long.
Oh, each exposure is 30
Yeah.
seconds long.
So what it does is the software automatically stacks all of the 30-second images to give you that star trail. Yeah. So you actually see, if I didn't leave it on so long, you'd see some of them have gaps between them. Because there's, I think, about 5 seconds interlude between each of the 30-second images.
There's a secondary streak.
Oh, here? Yeah, there's one there. And then that's assumably the rocket, right? Kind of coming down. Okay, so that's the first one. Next. Okay, so this was my attempt on August the 5th, 2026 at 1:33 a.m. in the morning. So this is when I started videoing that area of the moon to see whether I can capture the rocket, the Falcon rocket, because it was meant to be slamming into the moon, and I was hoping to capture it. And I used just a DLSR here on a small Takahashi 60mm telescope, and it was bar load 2.5 times. So what I've got here, and I don't know if you can see it very well, I've got a video. Is it going?
I think you just hit enter again.
Oh,
It's doing it.
Is it doing it?
It moved.
Oh, there you go. So I've lost my pointer again, Doug. I'll go with this one. But can you see here? Well, there's actually a little dark spot that's going across the face of the moon. Let me see if you can see it on this screen. Yeah. Can you see it? So there's two things about it. First of all, it was within a minute of when the Falcon rocket was meant to go into the moon. So 1:33. I don't know. Has anybody got an exact time? Exact time? Say again?
1:37:35.
Was it 1:37:35? I never realized it was that late. Okay. I always got on the internet, and once again, it's where you get your information from. I always saw 1:34 or 1:35. I never heard it exactly. It says 1:37:35. Okay. Yeah. Cool. Well, there are a couple of things here. Is that if you look at its trajectory of that little black object, whatever that was, it goes right over or very close to where the impact site was meant to go. It just happened to be, and it happened to be within minutes. I thought within 30 seconds. I'm wrong. It was within a few minutes of when that impact occurred. So I got really excited when I saw that. I thought, was I the only one who's actually captured something? Have I captured the rocket? But the answer is clearly no. And the way I kind of deduced that was, if you look, what you're not seeing there is how fast it's going, right? How long was it between going through that area of the moon? So I'm not kidding. What I did was print out a picture of the moon, worked out the diameter of the moon, worked out the circumference of the moon, drew a line on the trajectory of this little black object, and then suspended a cord to the center to work out approximately what it was. Well, it's doing that distance that you're seeing there in that thing in 0.2 seconds. Yeah. So if it were close to the moon, it's going incredibly fast. Yeah. And I think the rocket itself was reported to go about 5,400 miles per hour. So it wasn't that. And that is nowhere near. That's an order of magnitude faster than that would be, since that video is only 0.2 seconds. It's 0.2 seconds, and I've sped the video up as well for effect. And I also thought it might be the Januri spacecraft. I was getting all excited. I've got something, because the Januri spacecraft, the orbiter was meant to go over that site of impact about, within a few minutes of when the impact occurred. So I was thinking, oh, maybe I've got the spacecraft. But no, the spacecraft itself was going at around about 3,600 or so miles per hour. So it wasn't that either. So I got very excited when I got, but it wasn't what I was thinking I was going to get. But I had to prove it to myself that I hadn't got what I thought I was got. The other thing when I did imaging on the moon is that if you look up here, I did about 14 minutes of imaging. 14 minutes. And the other thing I saw was little areas that kept flashing. There were two areas specifically that kept flashing on and off. It's hard to see up here, but you see that's a bright object there and nothing here. But on this one, it's diminished here, and then there's a bright object here. It kept flashing, and I don't know what that flashing was. I started to think, oh, it could be something on the sensor. It could be some pixel that's just flickering. But the video itself, because I wasn't tracking, the actual picture of the moon was drifting across the sensor. So it was using different pixels every time for every image. So I don't know what those flashing objects were, but they are on my 14-minute image that I got while I was trying to capture the picture of the Falcon rocket. Any ideas? Anybody seen flashing things on the moon? Question at the back.
What if it's an alien spaceship?
Hi, guys. Our special friends are up there. It could be.
Could it be a meteorite impact?
But to be flashing kind of like on and off at different rates for 14 minutes?
A military payload that's classified and flooded out into system or space?
Could be. Well, we might have the Men in Black appearing soon at the door. I don't know. Anyway, it's a mystery to me. That's why I called that's why I said, what am I? If you start seeing these things, how do you find out what they are? I find it really difficult. I mean, I find it, I've not got an answer, but I thought it quite intriguing. So anyway, 14 minutes of image. Hope you enjoyed it. If you got any questions or got any ideas on what those flashy things can be, I'd love to hear from you. We can research it. Thank you very much.
When you hit it, the move in the lower right-hand corner is moving. What's that all about?
So that's actually the video of it,
Oh, up there.
of it flashing around here.
Okay.
Yeah. It doesn't show too well on here, but it
Right.
shows better on my computer.
Excellent. Okay, thank you, Chris. Chris brought door prizes. Huh? Yeah.
Okay, I figured that out. Okay, Paul, you guys know Paul Maley, sent us a member's minute, which he's asked me to stand up here and read. This is from Paul. He says, I am in Spain leading a group of 100 plus for the eclipse on August 12th. My team of 103 people saw this 1 minute 45 second total eclipse successfully from 2 locations in spite of haze and smoke from fires in Spain. 72 members were located at Hotel Londa, just south of Burgos, Spain, and the rest about 50 miles southwest. Also, I was asked by the Weather Channel to do a live interview about our presentation. Here's Paul down here on the Weather Channel. And expectations about 3 hours before totality. This is my 90th solar eclipse on behalf of the Johnson Space Center Astronomical Society. Next stop is the annular solar eclipse in Argentina in February, followed by the great 6-minute total eclipse on August 2nd of 2027 from our 2 ships in the Mediterranean. We have some space on our ship Azamara journey into the Mediterranean Sea for August 2nd, 2027, longest ever totality. If anyone is not committed and still thinking about it, and if ever see an eclipse, looks worthwhile, this is the one, because this is going to be a big one. 6 minutes, that's a whopper. There are a number of alternative locations in Africa and Egypt being the highest, but presently the military government forbids import of binoculars and telescopes into the country. Whether or not that happens on our ship, there is no such restrictions. We will be seeing 6 minutes, 8 seconds of totality. We'll be mobile and weather prospects are great. That eclipse will be my 92nd. So if you'd like to get more information about this, anyone interested to join the cruise can find details at www.eclipsetours.com and join in on some of Paul's adventures. That's from Paul. There's Paul there on the Weather Channel. Okay, we have another members minute contributed by Aaron Clevenson. These are ones where people send us ones, but they don't come themselves because for whatever reason. This is about Astronomy Day. And Astronomy Day, let's see what Aaron has to tell us. Astronomy Day, Houston 2026, Greater Houston Area Astronomy Clubs. So what is it? Astronomy Day, Houston. When? Saturday, September 19th from noon to midnight. Where? The Insperity Observatory in Humble, Texas. Why? To share the universe with the public. Who? The event is hosted by the Greater Houston Area Astronomy Clubs, FBAC, HAS, JSCAS, and NHAC. Okay, if you want to get more details, go to the website, www.astronomyday.net. They're going to have t-shirts this year, so you can get a t-shirt. We didn't have t-shirts last year, but they got them this year. Hosted by the Humble ISD and Insperity Observatory, but this is a 4 clubs event, and it belongs to the 4 astronomy clubs in the Greater Houston area. Here's what it looks like. This is the venue. This is the Jack Fields Elementary School over here, and this is the Insperity Observatory down here. Okay, and we set up deck scopes out here, green laser tours, the constellations done down here. There's outdoor presentations, indoor presentations, all kinds of good things. If you've never been there, the Insperity Observatory is impressive. They got some really good equipment, and if you've never been there, it's pretty cool. So you might want to go check this out. Whether you volunteer or not, it's really fun. Chris?
T-shirts are bought online.
Yes. Right. So, yeah, I was going to say that. So, Aaron, if you're on our distribution, send out information asking for volunteers. And you also sent out an email about ordering yourself a T-shirt too. So, thank you. Okay, here's a schedule. 12 to 3 is set up, and it's starting at 3 o'clock. Okay, tours to 7. He means tours of the observatory. You can go in there and see the observatory. Solar observing to 7. Outdoor presentations to 7. Activity tables to 10 o'clock. Indoor presentations to 10 o'clock. And then starting at 7 o'clock, out nighttime observing to 10. And that'll be the deck scopes out in the parking lot. And that'll also be the telescopes inside the observatory. And then starting at 8 o'clock, green laser tours. 10 to 12, cleanup, takedown. So, green laser tours, they go out there and show you where the constellations are with the green laser. Help you be able to recognize constellations in the sky.
just be mindful because it's close to the airport.
Oh, yes. And hopefully the people around the green lasers are thinking about that. Yeah, it's near the airport. So the point of this presentation is astronomers are needed for these activities. They need people for setup, sign-in table, welcome table, deck scopes. Last year we had several people from our club did deck scopes. I did a radio astronomy display, and Chris and Trevor had a solar telescope set up, I believe. And indoor presentations, we're looking for people to do outdoor presentation, green laser tours, activity tables, all clubs table, observatory, which would be the observatory staff, and tours, which would also be the observatory staff, and then help taking down. To volunteer, please send an email to Aaron at aaron@aaronclevenson.org. And he also sent out an email to all of us. You can look for, it's one of the many JSCAS emails that came out about this, and you can get Aaron's email that way too. But aaron@clevenson.org, and if you'd like to volunteer. It's a really good event. It was really good last year. They had, I don't know how many people they had. Hey, a lot of people there. So it's a good community event. And also, if you're looking for something, like you're trying to recommend, like I get a lot of people contact us and say, what kind of events do you have? This is a really great event to recommend to people who have families or groups, groups of kids or whatever that want to go to an event. This is really the thing to do. It's a once a year astronomy day. Very much set up for kids and students and families. So, questions? Does anybody have any questions that I might be able to answer? Thank you for not asking me any questions. All righty. Okay, that's about it. So, upcoming meetings in September on the 11th, Justin, right over there, there he is going to bring us from desktop to cosmos, transforming astronomy education with interactive software here at UH Clear Lake. And we're going to do something different. Paul, right there, Paul Lotz is going to start a series, a 4-part series, there he is, called Navigating Nebulae, Origins, Fates, and Features. So this is the first time we've ever done a 4-part series, but it'll be like 15 minutes each meeting, and Paul's going to bring it to us. So that's what we're doing. Next, door prizes. Did anybody not get a door prize ticket? You did not? Okay, so we got one here. Anybody else not get a door prize ticket? I got to look at these books Chris brought real quick. Oh my gosh. Here it is. Oh. Okay. Oh my goodness, Chris, these are very nice. You got both of the radio astronomy books. Okay. Those are very nice, Chris. Chris and Angie brought some really good door prizes for us. Wow, that's really good. Yes, thank you, Brandon. I'm tantalized by Chris's door prizes also. Okay, so get out your door prize ticket.
He said Angie's.
Angie, okay. Okay, I believe it. I thought they were going to be married to us. All right. Let's see. I'm trying to get down to the bottom because Justin told me he's never won a door prize. All the meetings Justin's gone to, he says he's never won a door prize. That is so sad. That is really, that's unbelievable. Okay, 085. 085. The last 3 numbers on your door prize ticket, 085. Oh, it's our main speaker, Leonard. Come on down here. Come on, Leonard. Okay, Leonard, I'm going to show you 3 things. I'm going to guess at what you might like. And then, okay, just let me tell you first, and then you can decide. Okay, we have this sign that says, objects and warning, objects and telescopes are farther than they appear. That's one possibility. Hold on, I know you don't look too happy about that. We also have astronomy socks. Okay, and then wait. And then I have, look at these books, come here. Any of these books that Chris and Angie brought tonight, look at these are outstanding books. Any of these books. Radio astronomy, I read this one, it's really good. You like any of those?
Absolutely.
Which one? Oh, the radio astronomy? Chris, are these both the same? Where's Chris?
Oh, possibly.
Are these two the same?
I'll see you.
Because there's a volume 1 and a volume 2 on this book. Are these the same? Observational methods, what's that one say? Yeah, good.
Okay,
Good.
awesome.
Here, I'll give you one that's not done up. All right, good.
Thanks, sir.
You're welcome. It's a good book, actually, I really like that. That's my favorite of the radio astronomy book. That's actually my favorite one. The other ones are kind of hard to read. Okay, next one. 083. 083. All right. Jacob, right?
Yeah.
All right, Jacob, come on over here. Okay, Jacob, I have any of these books. I have a moon map. I have the sign I just showed him. I got astronomy socks. I got basic physics, teach yourself physics. I have a book called The Rocket Makers. Tells about people who developed rockets for the Apollo program.
moon map.
You want the moon map?
Yeah.
All right.
Thank you.
Excellent. Good. All right, you got some good door prizes tonight. We're gonna go for a while here, a little bit. Okay, 086. 086. Justin, I'm really trying here, bud. I'm really trying. 086. Oh, it's Leonard's friend, wife. Who is that, Leonard? Okay, you came here. How are you related to Leonard?
I'm his wife.
Okay, you're his wife. I didn't want to say, I didn't want to assume anything. Did he tell you what to get?
No.
Oh. Are you an
I gave him
astronomer?
the opportunity.
Okay, I got all these books here. I also have astronomy socks.
Oy.
Oh, you want the socks? I got this sign about warning about the telescope.
Pushing that one.
Yeah, that.
Uh,
I got books about rocket makers. Oh, wait a minute. No, you don't want that.
okay.
I'll show you. I got this little
Oh.
blue thing that does that.
Leonard, help me out here.
Let's see. Oh, you know what? I have pictures from different shuttle missions. Okay. Oh, I know something.
Okay.
No, wait. I know something. Remember. Okay, this is good. I have black holes explained and a book that goes with it.
There. That
You probably like this one. It's of Great Courses. That's a good one.
Yeah.
Excellent.
Thank you.
Thank you. What's your name?
Sharon.
You didn't want to tell us you wrote that, did you? Sharon. That's Sharon, guys. We know who she is now. All right. 2 more at least. I'm trying, Justin. I know you're in here somewhere. Okay. 087. All these numbers sound the same. Mark, come on, man. You got any idea what you want of all the stuff I've been showing?
I'm a fan of the socks.
Okay, you got socks, but look at these books. I mean, these books are really outstanding. Look at these things. Look at these books that these guys brought. These are really good books.
Ooh, 100 Things to See in the Night Sky.
Yeah, that's really good.
That's a good one.
That is a good one.
Thank you.
Thank you. This really kind of ups the quality of our door prizes here quite a bit. You could get socks or you could get a good astronomy book. Okay, all right. We'll do 2 more door prizes. All right, here we go. Okay, gosh, every one of these numbers sounds exactly the same. 088. Read, come on,
Are you mixing
read.
those up?
Hey, Chris, do you want your bag back?
Yeah.
Oh, you want the bag? Hold on. There's something else in there. Oh, what is that? I don't want the, you want the bag? All right, here you go. All right, read.
Yeah, just socks.
You want the socks?
Yeah.
Okay, so look.
Take a pair.
Oh, no, look, you got the darker ones, you got the striped ones.
Let's do the dark ones.
Yeah, those are a little more manly.
Oh, yeah.
Manly socks. You don't want those striped ones.
Oh, no.
You look like the Wicked Witch of the West.
You only gets 1 pair?
Huh?
I thought you were gonna give up, last time they gave out, it was 3 pairs they got.
That never happened here. You're fired as vice president. That has never happened.
Okay, well, that was easy.
1 pair. 1 pair. 3 pairs. Rick, what are you talking about? That's crazy. Okay. Oh my goodness. Okay, 069. That's an early one. Justin, is that yours?
It's
There's Chris.
got any good books?
I got some real good books here. You can take any of your books you want, or you can take
the sign.
the warning.
Yeah.
Obviously, it tells whether farther than they appear.
I want that.
You want that one?
Yeah,
You know, Stan wanted this one. I was holding it for him for like 9 months, waiting for him to win it.
I give a leaving it for me.
No, he got one.
Is that one going to, is that one going to the cabinet?
Okay.
Okay, that's good. I'm glad when our speakers actually win a door prize. I'm glad Chris won that one. Okay. 075. 075.
That's me.
It's who?
I did last month.
Oh, you guys, come on. Come on down here. Oh, Leslie, come on.
I did last month.
Hey, Leslie, you need to look at these books we got. I also got moon maps and stuff like that. I also got milestones of flight. But look at these books Chris brought. These are really good ones. You like any of those? Ooh, look at that. Messier Optics book.
oh,
That's a good one.
that's a way over my head there.
I got milestones of flight. That's kind of cool. I got ones about the people who built rockets.
I've got that
Oh,
already.
you got that
Yeah.
book? I got Teach Yourself Physics.
No,
No.
that's way over my head.
No. I got Nova Adventures in Science.
Yeah.
Like that one?
How about I do the moon map?
Oh, you want to do a moon map?
Yeah,
Excellent.
thank you.
Moon
Because
maps are always a possibility, guys.
Well,
Speak
thing
up.
is, this one always goes with my binocs.
Yeah, yeah. All right.
Thank
Leslie.
you.
Outstanding.
I'm glad to see people that have gone to meetings like for 500 years and finally win a door prize. These guys have they've been at more meetings than I have. You know, when I first came, I won a lot of door prizes too myself. It's kind of weird. Okay, maybe 2 more. Okay, 068.
I'm in.
Max, come on. Come on, Max. Okay, Max. You want to treat yourself physics? We'll do one more after this, then we'll go. We got moon maps. We got socks that are striped. Striped socks. I got a DVD, Comet Collisions. I got all these books.
book about rockets.
The one about rockets?
Yeah.
Let me show you. The Rocket Makers. That's a really, that's
Yeah.
Yeah.
That's what I want.
cool. Milestones of Flight. You want 2 of them?
Yeah.
Take them. Bring them back when you're done.
Yeah.
Those actually came back already one time. Okay. One more and that's it. One more. Justin. Come on, this one's gonna be you. All right, last one. 084. All right, Tom, right? Come on, Tom. All right, Tom, I got moon maps. I got Wicked Witch of the West Sox, wherever they went. I've got, look at these books. These are excellent. Look at all these great books. I got one Nova Science Adventures of Science. Look at these. These are excellent books. You like any of those? You take that one? Very good. Okay. Thank you for coming. See you next week. Next week. What, Chris? What? I have no idea. Look on the calendar. It's what? Okay, yeah, somebody we know did not submit a Star Party report. So, okay, 22nd at Hack then. Okay, so we're done. See everybody at Mod Pizza and hope you come back next month. Thanks for coming. So you wanted the back, huh?